even though they have not seen the planet, by confining their observations to the star, they will be able to come to this conclusion. So that is radial velocity method. Next, let me explain transit method, which is the second indirect method. So remember again here, we don't see the planet. Our observation is purely on the star, and based on the behavior of the star, we come to the conclusion that there is a planet. So in radial velocity method, we were measuring the wobbling of the star. In transit method, what astronomers do is they constantly monitor the brightnesses of stars. So this is just an animation to show what is happening. In transit method, astronomers continuously monitor the brightnesses of stars. So if the star has a planet revolving around it, then when we are measuring the brightness, if the planet happens to pass in front of the star as seen from Earth, then for that brief duration of transit, the planet will block a little bit of light from the star. So what that means is the brightness of the star will come down for a short duration, then it will again go back to its original value. So initially the star has a certain brightness. When the planet comes in front, it is blocking a little bit of light from the star. The brightness comes down and then again it comes back. So remember again here, we don't see the planet. This is only an animation. What you are looking at or what I'm showing is only an animation for your visual understanding of this transit method. All they are doing is they are using the telescopes to continuously measure the brightnesses of stars, and they are hoping that when they are measuring the brightness for a long duration, some planet will transit in front, and through that they can discover the planet. Now, if a star has more than one planet, quite possible. Our own solar system has 8 planets and many other objects around it. So if there are, let's say, 2 planets, one is a small planet, the other is bigger, then as shown in this animation, the bigger planet will block a lot of light and the smaller planet will block a little bit of light. So when the smaller planet is transiting, the light from the star will dim down by a small amount. When the bigger planet is transiting, the light from the star will dim by a larger amount. And if the smaller planet is orbiting close to the star, then it will again and again and again come in front, and it will multiple times it will block the light. Whereas if the larger planet is orbiting far away, then the duration between 2 dips in brightness will be longer. So this is the essence of transit method. So in transit method, one can measure the size of the planet, how big it is. Remember, in radial velocity method, we could measure the mass of the planet, how massive something is. Here we are measuring how big it is, whether it is big or whether it is small, that can be measured. We can also measure whether the orbit of the planet is inclined in any way with respect to the plane of the sky. And we can also find out how far away the planet is and therefore what is its orbital time period. So radial velocity method and transit method are the 2 most successful indirect methods that have yielded a large number of exoplanet detections. But only problem with both those methods is that even though they have been very efficient in discovering exoplanets, still we have not seen those planets. Our observation is purely on the star. We only have indirect evidence that there are planets around those stars through those measurements. What will be really interesting is to actually see the extrasolar planets, taking pictures and seeing the star and the planets around it. That will be the most convincing thing. As I said in the beginning of the presentation, there are some challenges, there are some difficulties, there are some barriers in finding extrasolar planets directly because the planet is very small. The star is also small because it's very far away. The planet is even smaller than the star. It is sitting very close to the star. And the contrast in brightness between a star and a planet is very large. It is like a firefly on a LED light sitting next to a floodlight. So the contrast is also very large. So how do we actually detect these, take pictures of these extrasolar planets? This method is called direct imaging. Okay. The biggest difficulty in direct imaging is that when we look at these distant stars, the light from those stars are coming to us from light years of distance. But the last 100 kilometers of that light's journey is through the Earth's atmosphere. Our telescope is on the ground. it is trying to collect the light from those distant stars. So if the light has traveled for hundreds and thousands of years through the vastness of space, finally